Hello, I'm Mr. Bob, and welcome to my Algebra 1 review series. This video covers Chapter 10, Section 7, titled Using the Quadratic Formula. By the end of this video, you will have reviewed recent lessons describing the methods using the quadratic formula to solve quadratic equations. You will start this review by creating the quadratic formula from scratch. From there, you will review using the quadratic formula and finding approximate solutions. Finally, you will have reviewed the solving of a real-world problem requiring the use of a quadratic formula for its solution. If you would like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to my channel if you find this video to be helpful. Thank you. So, okay, before we get going, we're going to look at a definition. Quadratic formula. In a previous section, you solve quadratic equations by completing the square. If you complete the square of the general equation ax squared plus bx plus c equals 0, you can derive the quadratic formula, which will solve any quadratic equation. Okay, objective 1, using the quadratic formula. And before we can use it, we're going to actually derive it right now. We're starting with where that definition started us, and in fact, it's right here at the top of this slide too. I'll read it again. In a previous section, you solved quadratic equations by completing the square. If you complete the square of the general equation ax squared plus bx plus c equals 0, where a is not equal to 0, you can derive the quadratic formula, which will solve any quadratic equation. So let's start off. It says step 1. What should we do? It says write ax squared plus bx plus c equals 0 so that the coefficient x squared is equal to 1. So what that's going to mean is we're going to take now the ax right here. We have the a term and the ax right here. And we're going to divide, we did this previously. We're going to divide all the terms in this equation by a. And as you see, we have x squared plus bx over a plus c over a equals 0. We divided everything by a. Okay, so now we're ready to move into completing the square on what we've just done. So to complete the square, we're going to take and we're going to make some space like we always do. And we're going to go ahead and take half of the b term and square it. So here we have b over a is the b term. B over 2 times a is half of the b term. And then here's the square root. The squaring is right there. And whatever we add to this one side, as you know, we add to the other side. So we add b over 2a squared to both sides. Then once we've done that, we're going to take and we're going to start breaking this into part. We're going to break it into the sum of squares, which is the x plus b over 2a quantity squared. And then on the other side, we have the negative c over a. We moved our plus c over a right here. We moved this plus c over a to the other side. And here we moved it. And we still have the b over 2a squared. So leaving the left-hand side alone, we're now going to work on just the right side. So the first thing we're going to do is we're going to square the b over 2a squared. We're going to square that. So we end up with, on the entire side, still the minus c over a. Now it's plus b squared divided by 4a squared. We squared all the terms. Okay, so now we go ahead and we write the perfect square. So we have our perfect square right here. We're now going to put the c over a term create the same denominator. So we have to have c over a plus something so that we can add or subtract these numerators. So we're going to multiply both sides by 4a rather. Both sides be multiplied by 4a. So we're going to multiply the minus c over a by 4a, and it's 4ac divided by 4a squared plus b squared over 4a squared. So now we have like denominators. And now that we've done that, we're going to combine these two terms over the single denominator, and we have b squared minus 4ac over 4a squared. And on the left-hand side, we still have the quantity x plus b over 2a squared. That's our sum of squares, perfect square. And we're at the point where we're going to go ahead and solve the equation. Okay, we completed the square, we've completed our square, all the math is done. Now I'm rewriting it over here on this side. We're going to take the square root of both sides. The square root of the perfect square that we have over here, and the square root of b squared minus 4ac over 4a squared. And when we do that, we're going to end up with x plus b over 2a right here, when we take the square root of this term above it. But on the right-hand side, we're going to have the square root of b squared minus 4ac over 4a squared. Okay, so now that we're going to move the b over 2a, right here, the b over 2a, from the left-hand side of the equation over to the right side, like we've done on all the completing squares. So we'll have the x by itself on the left. And when we do that, we're going to have x equals, now it's minus b over 2a. It was plus b over 2a. Now it's minus b over 2a plus or minus the square root of b squared minus 4ac over 4a squared. So now that we have that, we have the x, we have the minus b over 2a plus or minus. Now we're pulling out the 4a at the bottom right. You have 4a squared. We can take that out from underneath the radical. And when we do, it's going to be 1 over 2a. Because this is division here. So it's still going to be division. And instead of 4a squared, it's now, we've taken the square root of it, it's now 2a. And this minus b over 2a, and we have plus or minus 1 over 2a times this the square root of b squared minus 4ac. So we're right there. Now all we have to do is simplify this. We're going to combine the minus b plus or minus the square root of b squared over 4ac and put it all over 2a. And that's it right here. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And this right here is your quadratic formula. And it was now derived from the standard quadratic equation. And as I said here, it will solve any quadratic equation you can throw at it. Very powerful stuff. Okay, example 1. Let's try and use the quadratic formula. So we're going to start with x squared. So our a term is already a 1. Plus 6 equals 5x. So we're going to have to juggle this around a little bit because, as you know, they want us to put it in the standard form. In doing that, we're going to start with the x squared, right here, x squared plus 6 equals 5x, and we're going to move the 5x to the left side so that we'll have x squared minus 5x plus 6 equals 0. And now we're going to take the quadratic equation. We have our formula. Now we're going to plunk in the values into our quadratic formula, and we're going to solve this. So what do? We're going to take minus, start right at the beginning, minus b. Well, what is b? b is minus 5. Minus 5. So we're going to start off right here. We're going to say minus the quantity minus 5. Right here. Minus the quantity of minus 5. Plus or minus. We go inside the radical. It's b squared. And what is b? It's minus 5. So minus 5 squared minus 4 times a. What is a? A happens to be a 1. So minus 4 times 1 times it's 6, it says, because they want the c, and the c term is a positive 6. So now we have minus the b, which is minus 5, plus or minus the square root of minus 5 squared minus 4 times 1 times 6 all over 2 times a, and a is a 1, so it's 2 times 1. So if we simplify this, we're going to end up with x equals 5. That's this part here, minus the minus 5. 5 plus or minus 1. Because these add to 1, by the way. So you end up with 1. 5 squared is 25, and you have minus 24. So 25 minus 24 is 1. So now it's plus or minus 1 all over 2, because the 2 times 1, it's over 2. And here's our two solutions. We have x equal 5 plus 1 over 2, or we can have x equal 5 minus 1 over 2, because of the plus or minus right here, the plus or minus. Okay? And given that, we have x equal 3. 5 plus 1 divided by 2, 6 divided by 2 is 3. Or 5 minus 1, 4 divided by 2 is 2. So there's our two terms, and we can check it. Let's just give it a shot. We can put in for, well, we don't have to put in anything. We have an x, we're going to put in a 3, I guess. So 3 squared plus 6 is equal to 5 times 3. Is it? 9 plus 6 is 15 equals 15. Yes. How about using the 2? 2 squared, 4, plus 6 is 10, is equal to 5 times 2, which is 10, correct? 4 plus 6, 10 equals 10. Yes. That, using the quadratic formula, solve that equation. Okay, example 1a, because there's going to be two problems. There's another slide. So we're going to do this stopping and starting twice. But go ahead, stop the video when you're ready and try this problem out. What they want you to do is use the quadratic formula and see if we can solve this. Okay? Go ahead and stop it and come back. I'll wait. Okay, let's go ahead and give the first one a shot. So what do we know? We know the a term is a 1, so we don't have to, we can just leave it like it is right now. It's not going to hurt anything. As a matter of fact, you really don't have to do anything with it to solve this problem. You can always put in the a term as whatever you want for an a term. So let's go ahead and try it out. We're going to say x equals minus b, and b is minus 2. So it's going to be minus a minus 2, okay, plus or minus the square root of b squared, which is minus 2 squared, minus 4ac, and we know that a is a 1, so we're just going to say times c, and the c is minus 8. Okay? And it's all over, right here, all over 2 times 1, which is 2. I could put the 1 in there just in case you, 2 times 1, and that would put a 1 up here. Well, we're just going to leave it at that, okay? So now we can move to the next step. The next step is x equals, this is 2 plus or minus the square root of 4 minus and minus, it's plus 32. Okay, so now we have over 2. And we're going to add these up here pretty soon, but we're going to, on the next go around here, x equals 2 plus and minus the square root of 36 divided by 2. We're going to take the square root of 36. X is equal to 2 plus or minus, square root of 32 is 6 over 2. And if we simplify that alone, it's going to be 2 over 2 is a 1. And it's plus or minus. 6 divided by 2 is a 3, plus or minus 3. So x, okay, x is going to be equal to 1 plus 3 equals 4, or it's going to be equal to x will equal 1 minus 3, which equals 2. So our two answers are x equals 4 and x equal 4, or x equal 2. We're going to do the next problem. Okay, so here we're looking at the second problem. Go ahead and stop the video and try it yourselves. See what you come up with and come on back. Okay, now that you've tried it, let's do it ourselves here. Let's do it. The problem now, we have this 117. It's on the right side. It needs to go on the left side because we need a c term. So we're going to say x squared minus 4x minus 117 is equal to 0. Now we can put the values into our quadratic formula. So a is a 1. It's minus 4 is our b, and minus 117 is our c. So we're going to say x equals minus 4, okay, plus or minus the square root, it's along in the beginning here, minus 4 squared minus 4 times 1 times negative 117. All over. Don't forget the all over. It's 2 times 1. 2 times 1. Okay? So now we're going to go down and write it again. X equals minus a minus 4 is 4. Plus or minus the square root of 4 squared minus negative 4 squared is 16. Minus a minus. We have minus times a minus. So it's a plus. Plus. And it's 4 times 117, and 4 times 117 is 468. 468. And this is all over 2. Okay, so now we can say x is equal to 4 plus or minus the square root of 16 plus 468 is 484. And that's over 2. And x plus equals 4 plus or minus the square root of 484 is 11. No, it's 22. 22. Let me create 22. 22. I was jumping the gun over 2. And that equals 2, 4 divided by 2 is 2 plus or minus 22 over 2 is 11. Okay? And so now we have our x. X is equal to 2 plus 11 is equal to 13, or x is equal to 2 minus 11 equals negative 9. And there's the solution. So example 2, it says finding an approximate solution. And what does that really mean? It says when the radicand in the quadratic formula is not a perfect square, like we've been getting perfect squares out of this so far, we take the square root of something, you can use a calculator to approximate the solution of an equation. So how would we do that? So we have solved 2x squared plus 4 minus 7 equals 0. So we can take and fill out the equation right away. We can say minus 4, because we have a 4, so it's minus 4, plus or minus the square root of 4 squared. Here's 4. Oh, I see that we're missing an x right there. I'll fix it after we're done talking about it. So 4 is squared minus 4 times 2, which is the a term, times minus 7, which is the c term, over 2 times the a term, which is 2. And when we move on and simplify that a little bit, we get minus 4 plus or minus 16 plus 56 squared. Okay, 56. And then when over 4, and then that can be converted into minus 4 plus or minus the square root of 72 over 4. So x is now equal to negative 4 plus the square root of 72 over 4, or it's x is equal to negative 4 minus the square root of 72 over 4. And since we can't take the square root and get that's not a perfect square by any means, we're going to have to take the calculator and get the square root of 72. And we see here that the square root of 72 is 8 8.49. Okay, so in both equations we have minus 4 plus 8.49, and or we also have, and it's approximate. These are approximate answers because we took an approximation of the square root of 72. So let's already see the squiggly line right here. Right here is a squiggly line. It's not equal, it's approximately equal. Minus 4 minus 8.49. Divided by 4, each one divided by 4. And when we do that, we get x approximately equal to 1.12, okay, or x approximately equal to negative 3.12. That's what they mean by an approximate solution, is because we had to use a calculator to come up with the square root of 72. Okay, so example 2, there's going to be 2 problems. I'm going to have 2 slides. Check your understanding. So we're going to solve these 2 equations. There's one on the next slide, I just said, and round to the nearest 100. So why don't you pause the video, try this out. When you come back, we'll do it together. Okay, now that you're back, let's give it a try. So everything's in the right order, so we're in good shape. We can just start off by saying x is equal to minus b minus 5, okay, plus or minus the square root of what? Of 5 squared minus 4 times a is minus 3 times minus 2. So there's parens around these guys, right? Okay, and that's all over what? 2 times minus 3, 2 times minus 3, 2a. So let's move on to the next. X is equal to minus 5 plus or minus the square root of 25. And this is minus times minus times minus. It's a negative. And it's negative 4, 12, 24. Okay, 24. So, and it's a minus 24 over minus 6. Next, x equals minus 5 plus or minus the square root of 25 minus 24 is 1 over minus 6. And let's see what we can do with that. Well, there's not a whole lot we can do here. We're just going to say it's minus 5 plus square root of 1 is 1 over minus 6, or it's minus 5 minus 1 over minus 6. Okay, excuse my dog for barking out there, disturbing this. So let's continue on. So now we can say that x is equal to minus 5 plus 1 over minus 2. So it's minus 5 plus 1 is negative 4 over negative 2. That equals 2. Did I do that right? Oh, that ain't a 2. Sorry. I can't even read my own writing, and I'm sorry about that. It's not what we've got here. It's negative 4 over 6. Sorry. Over negative 6. And that equals negative 4 over negative 6 is equal to 0.67, because it's 0.666666. It's 2/3, and it's 67. 0.67. And then the other one is negative 6 over negative 6, or it's equal to negative 6 over negative 6, which is equal to 1. So I'll write that over here. X is equal to 0.67, or x is equal to 1. Okay, now for the next one. Okay, example 2b, which is the second problem. It's to solve the equations and round to the nearest hundredth. So go ahead and try it on your own. When you get done, we'll come back and we'll do it together. Okay, we're assuming you're back. So let's give it a try. So we're going to start off by writing the quadratic formula and filling it in as we go. So it's x equals minus 2. B is minus 2. Minus a minus 2. Plus or minus the square root of what? The square root of b minus 2 squared minus 4 times a, which is 7, times c, which is minus 8. I'll extend out our radical here a little bit. And that's all over what? 2a. 2 times 7. So let's go to the next step. X equals minus a minus 2, plus or minus the square root of negative 2 squared is 4, minus times a minus is a positive. So it looks like we're going to get, what does that come out to? Let's see. Okay, according to my calculator, negative 4 times 7 times negative 8 is positive. Let me get the positive in here. 224. And that's all over 14. Okay. And now we have x is equal to 2 plus or minus the square root of 4 plus 224 is 228 over 14. So now what we need to do is we need to take the square root of 228, and that's going to be, I'm going to do it right here, x equals 2 plus or minus the square root of 220, and whatever that comes out to. I did that also when I was offline here, 15.0 rounded, and that's over 14. So now we can go over here, we'll say that x is equal to 2 plus 15.10 over 14, or it's 2 minus 15.10 over 14. And that comes out to be x ends up, when you take the 17, 15 plus 2 is 17. 1710 divided by 14 is equal to 1.22. And the other x is equal to 13 divided by 13.1 divided by 14, and that is equal to 0.94. I hope that worked out for you. And sorry for the dog barking earlier. Hope she does that every once in a while. Okay, example 3, a real world problem. And these are fun, these types of problems. You get a lot of them in the future. If you stay in mathematics or engineering or any science that requires mathematics, you'll see a lot of these kinds of problems, and they're a lot of fun to solve. Suppose the football player kicks a ball and gives it an initial upward velocity of 47 feet per second. The starting height of the football is 3 feet above the ground. If no one catches the football, how long will it be in the air? So what's it going to do? It's going to kick it, and it's going to go up at a rate of 47 feet per second and then fall down. It'll be going down and slowing down and changing direction because of gravity, right? The ball won't go up forever. It's going to slow down until finally it turns around and goes back to the earth. So let's solve the problem. What is step 1? Use the vertical motion formula. We've used it before. What is it? It's the height is equal to minus 16t squared plus vt, with the velocity, times t plus c. That's a constant. It's the initial position. That's what that stands for in reality. So that is 0. We're going to create a quadratic equation here. 0 equals negative 16t squared plus 47t plus 3. That just defined our entire problem. Now we're going to solve the quadratic formula. We're using the quadratic formula. We're going to solve this equation. And what do we get? We get the minus b. What is b? B is 47. So it's minus 47. You see it right here, minus 47. Plus or minus the square root of 47 squared minus 4 times a. A is minus 16. Right here, minus 16 is our a term, plus 3. 3 is our c term. 3 is the initial starting height of the ball above the ground when it's kicked. And it's all divided by what? It's divided by 2 times a, the minus 16. So when we work out the mathematics, we still have the minus 47, plus or minus 2209, which is 47 squared, plus 192, which is minus 4 times minus 16 times 3, and then it's all over 32, minus 32. So now we're going to combine the terms under the radical. So here we get in the t, oh, where's my pen? There it goes. T minus 47 plus or minus 2401, the square root of 2401 divided by 32. Well, what is the square root of 2401? Lo and behold, you can take that and get that square root. It's 49. The square root of 49 squared is 2401. So you take minus 47 and you can add 49 to it. Or you got minus 47 and you can subtract 41 from it. And it's both terms, the t value, the time in the air, is both divided by 32. So we're going to get, well, I should have done either one, the plus and the minus. I'm going to fix that after. This should have been one term should have been a plus, and the other side over here should have been the minus. So in either way, you're going to get t is equal to minus 0.606 seconds, or t is equal to t equals 3 seconds. Well, why is the t minus 0.06 seconds in red? It's because it's an illegal number. You can't use it. And why can you not use it? Because time doesn't go backwards. You can't have a negative time. We kick the ball and time goes forward from that point. It doesn't go negative. So the only thing you can have is the positive 3. It's in the air for 3 seconds. And I will fix that little problem I pointed out to you. Okay, example 3, check your understanding. It's basically the same problem. It's a little more difficult maybe, but go ahead and give it a try. When you come back, we'll try and do it together. Okay, now that you're back, let's do what it says. It says substitute, part A, substitute the values into the vertical motion formula. Okay, the vertical motion formula, you all recall, is h to the height is equal to minus 16 t squared. And now we're going to plus vt, and vt is 38.4 t, and it's plus the starting height, which is 3.5. So there is the formula. We now have the formula. So now we can, let's go ahead and do this using the quadratic formula. So it says B over here, solve it. So if no one catches the ball, the football, how long will it be in the air? So let's go ahead and I'll write, save us room if we need it. I'm going to write on this side. I'll start under the A part. So I'm going to say X is equal to, what? Minus B. B is 38.4. So it's minus 38.4 plus or minus the square root of B squared, 38.4 squared, and it's a minus 16 is in here, it's minus 4, and it's a plus, so it's going to be a positive. So it's positive 4 times 16, I got rid of that negative right there, and times 3.5. I got rid of the negative when I multiplied it right here, for this plus sign here. And so that's that, and then that is all over something. It's all over, it's a long one, 2 times negative 16. Okay, the next, we'll write it one more time. X equals negative 38.4 plus or minus the square root of 38.4 squared, and I did that. It comes out to 1474.36. Okay, and that's that term, and then it's plus 64 times 3.5, and that comes out to 224. 224. Okay, and that is now over negative 32. Now we're going to combine these terms under the radical. So we're going to say x is equal to negative 38.4 plus or minus under the radical 1474.36 plus 224 comes out to 1698.36. 1698.36. And this is all over negative 32. Okay, so now we're going to take the square root of 1698.36. And what does that equal to? So x equals negative 38.4 plus or minus, no longer going to have the radical, and that answer is 41.21. 41.21. And that is over negative 32. So now we're at the point where we can pretty much start simplifying it. So the first x term is going to be negative 38.4 plus 41.21. 41.21 over negative 32. The next x term is minus 38.4 minus 41.21 over negative 32. And if we look at those, let's look at the top one. The top one, negative 38.4 plus 41.21 divided by 32. If I look at that, negative 38, it's going to come out to 0.087. So that's going to come out to 0.087. Okay, and this is minus and a positive, so this is going to be a negative number, right? Negative 0.087. This next term here is negative 38.4. So negative 38.4 plus 41.21, negative 41.21. So it's negative 38.4 minus 41.21 divided by 32 is going to be negative 79.61 divided by negative 32. I'll write that in there because this is the one that we're going to want. It's going to end up being negative, where to go? Negative 79.61 divided by negative 32, and that equals 2.5. Let's just say 2.5. And then negatives cancel. It's about 2.5 seconds. So there's our answer. And why can it not be, we talked about this before, why can it not be the negative 0.087? Because this is a real world problem and time only moves forward. We can't go in the past. So it's always a 0 or greater for time. So here's our time of 2.5 seconds. Okay, for objective 2, we're just going to be talking about choosing appropriate methods because we've learned a bunch of different methods now. You learned pretty much basically all of them. And what they want to do is just how do you know which one to use? Because there's some going to be, the quadratic formula is nice, but it's a little tougher. If you could just easily factor something, why would you factor it in like 2 easy steps maybe, where it would take you all those steps to do the quadratic formula? Now, if you have a computer doing it, nobody cares. Well, if you're doing it by hand, then we start to worry about it. So it says there are methods of solving the quadratic equation. You can always use quadratic formula, but sometimes there might be an easier method. So what are the methods? We have graphing, square roots, factoring, completing the square, and finally the quadratic formula. And when do you use it? So you use graphing. Use if you have a graphing calculator handy. Otherwise, it can be problematic doing it by hand. You got to draw the graph, and depending on how complex your curves are, it's probably better to maybe not do graphing unless you have a calculator to do it. Square roots, use if the equation has no x term. So if it's like x squared plus 9, then use square roots, because everything is a square, x and 3, right? So plus 3, minus 3. Factoring, use if you can factor it easily. If you can look at it and you can say, oh, I can see this, 12 is a 3 and a 4, 3 and a 4 give me a 7. And it's easy. It kind of comes up easy in your head. Your math says, oh yeah, let's go that route. It's faster. Completing the square, use if your x term is a 1. You cannot factor the equation easily. So it's a little tougher to factor it, but it has to be a 1. So you're going to end up dividing by whatever the a term was. If you had an a term, makes it a little more complex. B over whatever, right? So, and then the quadratic formula. Use if the quadratic formula can be factored easily or at all. Use if the equation cannot, if the equation cannot be factored easily or even at all. If you look at it and say, I can't figure that out. So then use the quadratic formula. It's just that straightforward. You have to get your calculator out and give it a shot, but so here are some examples as choosing an appropriate method. Example 4. So which method would you choose to solve the quadratic equation and justify it? So look, they've given us 5 to look at, and how would we do it? So 2x squared minus 6 equals 0. Well, they said if there's no x term, you might as well use the square roots. And that's what they say here too. There's no x term, so square roots, there is no x term. It's a good place to start. How about 6x squared plus 13x minus 17 equals 0? Well, that's pretty complex. You've got a 6 in there. And if we divide it by the 6, if we tried to, it would be 13 over 6 and 17 over 6. It gets odd numbers. You're better off using the quadratic formula. It says right here, the quadratic formula. The equation cannot be factored very easy, that's for sure. How about x squared plus 2x minus 15 equals 0? Well, you can factor that. The equation is easily factored. Okay, so, and how does that? 5 and a 3, right? 15 times 3, 5 times 3 is 15, and a 2 can be from a 5, you can subtract 3 and get a 2, and it's a negative, right? So you know that it's a positive 2, so you know that the larger term is going to be the 5, and the smaller term is going to be the 2, and 5 minus is going to be a 3. 5 minus 3 is 2. I factored it in my head right there. Okay, the next one, 16x squared minus 96 plus 45. Well, I guess I would go with the quadratic formula. Just looking at it right off the bat, nothing pops. The numbers aren't easy to deal with. We couldn't complete the square. We can't get rid of that 16 that easily. Okay, and then the last one, x squared minus 7x plus 4. Again, although it might be nice, but can you take a 4 and get any factors of 4 that'll give you a 7? I don't think so. Okay, 4 and a 1, 2 and a 2. Sorry, you can't get a 7. So it's going to have to go to the quadratic formula for that one. Okay. Okay, example 4, check your understanding. Which method would you choose? And justify your reasoning. So this is our last slide of this section, so let's look at it here. Problem A. Oh, you're going to stop. Why don't you stop the video and try it? And tell me what would you use? Go ahead and give it a shot. Okay, here we go. 13x squared minus 5 plus 21 equals 0. Well, I don't see where I'm going to be able to factor that really in any way. 21, 13, 5, nothing jumps out at me. I'm going to say, and it is true, it's the quadratic formula is what you're going to have to use for that. Quadratic formula. Let me see if I can write that in here. Quadratic formula. Okay. How about x squared minus x minus 30 equals 0? Can you factor that? Well, 30 is 6 times 5, and I can get a 1 with a 6 and a 5. 6 minus 5, or minus 6 plus 5. That would be my answer. I'm going to say factoring. Factoring. And the last one, 144x squared equals 25. Well, I would probably end up moving the 25 to be negative 25, and 144 x squared and 25, they're all squares. 144 is 12, x squared is x times x, and 25, so this one's going to be square roots. There's no x term. Certainly going to be square root. Oops, square root. Okay. Thank you.